orbital.
The chamber pressure looks good. Following up. Roger, roll, Atlantic.
Water towers can fly!
Tango Delta nominal.
Flighting down speed off. Bring in, speed off. Off.
Yikes. You bet. Concur. We don't need any more of these.
Hello everyone, welcome to today's webcast of Launch Vehicle 6 or LV0006, Astra's third orbital launch attempt. Today's mission is a demonstration launch for Astra in partnership with the United States Space Force. The flight's taking place from Kodiak Island, Alaska, and we are coming to you live today from Astra's headquarters in Alameda, California, where teams in Mission Control are conducting the launch attempt. My name is Thomas Burkhart, News Director for NASASpaceflight.com, and one of your hosts for today's launch. I'm joined by Carolina Grossman, Director of Product Management at Astra. Carolina, how are things looking for today's launch?
Thanks, Thomas. We are just inside T-minus 50 minutes from launch. We are tracking upper level winds, but our latest weather data looks good, and the team has begun loading propellant onto the vehicle.
That is excellent to hear. Thanks, Carolina. As usual, throughout the course of our broadcast, we'll be taking your questions live. So if you have questions about what you're seeing, what's going on, please feel free to throw them in the chat and tag us with @NASASpaceflight. We'll be getting through as many of those questions as we can over the course of the countdown and the launch. But really quick, we're going to take a look at the static fire test, which led into today's launch campaign.
The hot fire test is the final test of the entire integrated launch system, where we get to test every single component of the rocket. With every new version of the rocket, we perform a hot fire test that allows us to make sure that all of the upgrades work before we launch the rocket into space. Once we're done with this test, we pack up the rocket and Astra is on its way to orbit.
So as we mentioned, today's mission is a test flight for the United States Space Force, and our first question is talking about the payload on board today. So Carolina, what is in that payload fairing for today's launch?
Absolutely. We have a payload from the U.S. Space Force, part of the Space Test Program. It is a test payload, so we will not be deploying it on today's mission.
Gotcha. And this is, of course, Astra's third orbital launch attempt, and I believe that makes today's flight the first Astra launch with an actual payload on board.
That's right. This is our first commercial payload on board an Astra rocket, which is very exciting.
And I want to talk about where today's launch is lifting off from. We're looking at the beautiful launch site out in Kodiak, Alaska, which was also the home of the two prior Rocket 3 orbital launch attempts, correct?
Yes, that's right. Our scenic launch pad in Kodiak, Alaska is what you're looking at now on your screen. Kodiak is 250 miles south of Anchorage and is the second largest island in the United States after the big island of Hawaii. You might be surprised, but the weather is actually not as cold there as you might think. Typically, highs are in the 60s and lows are in the 50s Fahrenheit this time of year. Kodiak is the home of the Pacific Spaceport Complex, Alaska, also known as PSCA, which first opened in 1998 and is a launching site for suborbital and orbital launch vehicles in the US. That's where LV6 will launch from today. And we'd like to take a moment now to thank all of the PSCA team for being an instrumental part of our launch and continuing to help us safely and efficiently operate in beautiful Kodiak.
It is an absolutely gorgeous launch site, and we're getting treated to some beautiful views of today's launch. And like we said, we're just over 50 minutes away. We're currently targeting a liftoff of 2 p.m. Pacific time. And that is the opening of a window. And as you can see on the screen, with the one watch item we are looking at is winds. But I believe right now everything is tracking on time for launch. Is that right?
That's right. So far, we are moving smoothly through our countdown procedure.
That is great to hear. You will also be hearing the countdown net as the launch controllers go through their various procedures. You'll hear that every once in a while. That'll give another update on how the countdown is progressing. And as we look at mission control here in Alameda, I'll point out, well, one of them has stepped out. I'll point out the launch conductor, which is Charles Hoffman in the Mohawk in the back row there. He will be joined on his right shortly by launch director, Chris Thompson. And that is the half a dozen or so folks here in launch control in Alameda, and they are joined by another crew that is similarly small out there in Kodiak, isn't that right?
That's right. We have our red team of 6 that's out there in Alaska. They do everything that we need to do to set up our whole launch site, prepare the rocket, and it's been wonderful to have a very small and nimble team, especially as we continue to work through the COVID-19 pandemic. The team is working very hard to stay safe out there, and we want to thank them for all that they do to help us operate so efficiently.
We'll be able to see the teams hard at work today, and what we're also seeing now is the beginning of propellant load operations. Just before this stream started, the teams pulled go for propellant load, and you can see the rocket starting to get frosty on the outside. Let's talk a little bit about that. The Astra Rocket 3 series is fueled by kerosene and liquid oxygen. The kerosene is ambient temperature, which is why you're going to see that frost line kind of partway up the rocket there, not the entire rocket, because only the liquid oxygen tank, which is on top, is going to cause the air around the rocket to condense, and you'll see that ice forming on the outside, as we see with many, many launch vehicles that we watch here at NASASpaceflight. And as that frost progresses, we'll get that visual indicator of how fuel load is going. And that will continue until just a few minutes before launch. Diving back into some more questions here, we have one asking about potential future reusability. I don't believe Astra is going to go that route. Can you talk a little bit about why, Carolina?
Right, we are focused on producing expendable rockets. There's a few reasons. One is just from a physics perspective, you have to carry extra mass to make a rocket that can withstand reusable flight. And we also get economies of scale as we make more and more of the same type of rocket, since we can save that refurbishment cost. And finally, we are designed our rocket as a small rocket that is not designed to be carrying people. We're sending payloads up into space. And so we want to focus on making something as efficient and simple as possible. One of our values here at Astra is that simple scales. So we don't want to add a lot of mass and try and reuse things and build in that extra engineering work. So expendable design, we believe, is going to be the path to help us get up to scale.
That simple scales philosophy is written all over the place here at the factory. You see it everywhere. And those simple, small launch vehicles that you can mass produce to the point where your serial number needs 3 zeros at the beginning of it, so you have room for all those future rockets.
Absolutely. We are hoping to provide daily space delivery someday. So those 3 zeros, we can't wait to have LV 9999 under our belt.
And we can see launch conductor Chris Hoffman in the back row there, and he is now joined by Chris Thompson to his right, our left. Those are your launch conductor and launch director for today's launch. As the countdown proceeds, and we're going to let some more questions come into the queue here. In the meantime, let's listen into the countdown net, and as the teams continue with the countdown.
4 FTS checkouts.
Of course, right on cue as we go to the countdown, they get a little quiet as they continue to work through their procedures, but we're going to continue listening into them throughout the countdown. In the meantime, we'll keep taking some questions, Carolina. And right now we're looking at rocket 3.3, that version of Astra's rocket. Can you talk a little bit about how the previous versions of the rocket that we've seen fly before have been upgraded and changed to get to this version?
Absolutely. So this is our latest and greatest rocket. What we have done in the time since our last flight in December, we first of all fixed the issue that caused us to fall short of orbit. So that was an issue with our propellant mixture ratio. We've resolved that issue. We've also extended the first stage tanks in order to allow more propellant to load onto the vehicle so we can get more payload. And we've also consolidated a lot of the components on the upper stage in order to, again, get more payload capability out of our rocket.
And this is still a dedicated small launch vehicle, and we've got a question in chat asking if Astra has any plans for a bigger rocket after this.
Yes, our rockets may get a little bit bigger as we proceed and adjust our plans for our customers. We are, of course, looking to serve what our customers' needs first and foremost. And we've made changes and continue to improve on our rocket. Our Rocket 2 was smaller than our Rocket 3. We increased the diameter, and we'll continue to make small iterations. It's a big part of our philosophy at Astra to make iterative changes and improvements in order to best serve what our customers need.
And I believe that it was a length change, right? That first stage got stretched a little bit for extra propellant.
That's correct.
Countdown is proceeding. I'm going to keep coming with some questions here. We have a question asking what material is the structure of the rocket made out of?
Yeah, most of the rocket that you see here is made out of really simple materials. We tend to shy away from things like carbon fiber and 3D printing as much as possible so that we can mass produce it and continue to scale. A lot of what you see comes in as sheets of metal into our factory, and our incredibly talented machine shop team turns that into the vehicle that you see today.
And we can see that bare aluminum on that first stage looks really, really cool. It's a cool looking rocket.
Absolutely. I'm a little biased, but I agree.
So we're looking at Kodiak right now, and we have a question asking if there are other launch sites currently being considered. What kind of things does Astra look for in potential launch sites?
Yeah, again, we're looking to serve our customers and the needs that they have, but we are identifying new launch sites in the United States, and that's what we can say about our plans right now.
What kind of orbits are you able to access from Kodiak with this initial launch site?
Yeah, we're looking at high inclination orbits like sun synchronous orbit, which is a location that many of our customers want to go to.
I know this particular flight is going towards a 70-degree inclination, so not quite polar, but a high inclination orbit, just going up to low Earth orbit, 415 kilometers altitude. And that'll be that target orbit for, again, that mass simulator payload on the upper stage, which will not be deployed in any way, just a test payload to demonstrate Astra's orbital capability.
That's right.
So how did this rocket get up to Kodiak? We're here at the factory here in Alameda, California, and well, it's not super close to Kodiak, so how did that rocket get up there?
Yeah, one of, I think, the most unique things about Astra's launch system is that a lot of what you see on your screen fits inside standard shipping containers. So if you joined us at the top of the broadcast, we had a video of our static fire test that showed this exact same material being deployed to our test site a couple of hours away from our headquarters. We literally load everything into shipping containers and truck it out and ship it out by boat to where it needs to go. It's something that allows us to be extremely responsive when we're setting up a test site or a launch site, and one of the reasons why the Space Force was excited to work with us.
And that rocket, all the hardware that goes around it, and the red team, which travels out to the launch site with the rocket, arrived there just a week before this launch attempt, right?
Right, just about. It is a very precise orchestration of getting everything set up, but we are able to do it very quickly.
And that's part of not only the simple scales philosophy, where you want to keep your launch teams and the hardware involved as simple as possible, but also the ability to launch from anywhere, or at least anywhere with a concrete pad and an internet connection, right?
That's right.
And as well as that quick launch turnaround, because again, if Astra's going to one day achieve that daily launch cadence, you don't want to be out on the pad for weeks at a time.
Right. We think that it gives us an ability to be very responsive both in terms of timing between launches and helping us to accelerate our cadence, as well as the locations that we're able to fly out of.
So another question we're having here, we're talking about the simple infrastructure around the rocket, but is there still a water deluge system that we're going to see near liftoff?
Yes, absolutely. Just about 15 minutes before T0, we will perform a test of the deluge system, and you'll see that very beautiful spray of water come out from near the base of the rocket, which is a nice indicator that we are approaching our terminal count.
And I know that seeing some of the prior tests, we saw that static fire video, we've seen video from prior launches, and that water deluge system is dramatic and very visible, so we'll definitely be keeping an eye out for that. Keep your questions coming. Again, tag us with @NASASpaceflight if you have more questions for us in chat. In the meantime, let's go ahead and listen back into the countdown net as the countdown proceeds. And joining me now is Dr. Adam London, co-founder and CTO of Astra. Adam, thank you so much for taking some time to join us today.
Happy to be here. Exciting day.
So how are you feeling about today's launch attempt?
We're excited. We're ready to do this. We spent a lot of time getting our rocket ready, and now is the time to see how it goes.
So what are your responsibilities here as the CTO of Astra?
I lead sort of the overall technical decision and architecture of the vehicle, and also help work on advanced technologies.
And talk about some of those upgrades. We're coming to Rocket 3.3, first launch of this version of the rocket, and there's been some upgrades since 3.2. Can you talk a little bit about what's changed for this launch?
Sure. Our first focus was making sure that we understood and fixed the issues that caused the previous rocket to not quite make orbit. And so we've addressed the fuel consumption and mixture ratio control situations. That was one thing. But in addition, we made other improvements, including lengthening the rocket a little bit, so it's about 5 feet longer than the previous one, as well as improving the performance of the upper stage.
And how do you balance making those kind of upgrades and tweaks when you learn from every single flight when you have several rockets in various stages of production at any one time?
It's tricky, but we try to, ultimately, our goal is to build batches. And so the next rocket, LV0007, is on the floor over here getting built. And if this rocket goes well, it will be an identical copy. If from this rocket we learn things that make us want to change a few things, we'll make some small changes in it and continue moving along in that direction.
And how is Astra currently working today to transition not just between launches and learning from every single flight, but also transitioning towards your future rockets, maybe scaling it up to larger payload capabilities or bringing down launch cadence time so you can eventually achieve that daily launch cadence?
Yeah, a lot of what we're doing now is thinking about production. And so the Rocket 3 series will be the one that we first produce at rate. And so 0007 will be next, and then 0008, 0009. In that process, we'll be learning and taking those learnings to apply them to future improvements of the rocket.
I'm going to take a question here from chat here. They want to ask Dr. London, what is the most fun part of rocket design? Because I know you have some very interesting rocket design programs in your history.
The most fun part is always watching the rocket's light, either the engines in the test cell or the rocket as it's getting ready to leave the pad.
And lastly, I want to ask you one last question before we let you go. On launch day here, thank you so much for joining our sort of pre-launch, pre-game interview. Once we are getting close to T0, what are you going to be doing and where are you going to be watching the launch from?
Well, once we get to T0, there's not much we can do. The rocket flies itself, and so I'll be sitting there with the rest of the team enjoying the video and watching the data to see how it performs.
Adam, thank you so much for joining us. We're all looking very much forward to this launch, and best of luck to you and the teams. And just, yeah, thanks so much for taking some time with us today.
Thanks for being here, and looking forward to seeing this flight.
All right, let's listen back into the countdown, Ed, as the countdown proceeds past T-minus 33 minutes and counting. And Karen, Lena, let's talk a little bit about why that countdown is a little quiet right now. Sounds like things just might be going really smoothly.
Yes, we are at T-minus 31 minutes now, and things appear to be proceeding nominally.
We always love to hear things are going nominally. We'll keep listening in every once in a while, but sometimes a quiet countdown net is a good countdown net, meaning the teams are talking on other nets to resolve any minor things, but sounds like no major issues being worked at this time.
That's right. No news is good news at the moment.
Absolutely. And we're coming up on that T-minus 30-minute mark. Again, if you're just joining us, liftoff is targeted currently for 2 p.m. Pacific time, and we'll give you any updates if that changes, but so far the countdown proceeding nominally. And we're going to keep going through some questions in chat, so if you have more of those questions, throw them in the chat, tag us with @NASASpaceflight, and we're going to keep answering those as best we can. So let's talk a little bit about how far away launch control is from the launch pad, the pad up in Kodiak, Alaska.
Well, you can see the pad up is in Kodiak, Alaska, and our launch control is actually right behind us here in our headquarters in Alameda. So it is very, very far away. We have our team at Kodiak, the red team that helps to set up and prepare everything for launch on site. They have fallen back to a safe distance from the pad, but our launch control is entirely here in Alameda. We have our mission control camera that you've been seeing, and we also have the team of engineers who has worked on the system and is looking at data dispersed throughout our factory.
And that red team, which has backed away from the launch site, obviously now that we're into propellant load, is not actively controlling the launch then. That's all on the people sitting behind us here in California.
Right, the vehicle is entirely controlled from our launch control here in Alameda.
And then here in Alameda is not just mission control, we're in the middle of a giant factory space. Does all of the manufacturing still happen here in California?
Yes, actually, all of our manufacturing still happens here at our headquarters in Alameda, and we also do a bunch of our engine testing here on site as well. It's pretty amazing to see an engine built on a benchtop and rolled over to our test facility literally across the road on the stand and fired off in the same day.
We definitely appreciated the opportunity to get a tour of those factory and test facilities last week prior to this launch campaign, and we're looking forward to sharing that on the NASA Spaceflight channel, so stay tuned for that on NASA Spaceflight on YouTube. In the meantime, 28 minutes and counting, teams continuing to count down towards the launch of Launch Vehicle 0006, Astra's third orbital launch attempt. I want to talk a little bit about the teams that have built this rocket, tested this rocket, and are now conducting the launch attempt. Well, around here in Alameda, we've seen a lot of people coming from a lot of different backgrounds. Even at the high VP level, there's a lot of people coming with maybe not even aerospace experience, coming from a lot of different industries. Can you talk a little bit about how that makes Astra a bit of a different rocket company?
Yeah, absolutely. You know, we're here in the San Francisco Bay Area, which is not a typical place where you find a lot of rocket manufacturers. So we like to take advantage and try and think differently as we're trying to build a rocket in a way that no one has ever built one before. So we do have a lot of folks who come from Silicon Valley companies. We have folks from the automotive industry. We really value that diversity of thinking as we try and build differently.
And we have a question in chat about someone who may be potentially looking to join that team, wondering if Astra has an intern program?
Yes, we do love having interns here at Astra. You can learn more at our careers page on the Astra website. But we've had, as our summer's wrapping up, we've had a wonderful group of interns that have just wrapped up their summers, and we hope to welcome many of them back.
Excellent. Another question in chat. Again, we are targeting a liftoff time of 2 p.m. Pacific time, but a question asking how long does that launch window remain open for? Because that's just the opening of today's attempt.
Right. So if we're, for any reason, have to scrub today's launch, we do have launch attempt. Our launch window extends through September 11th, so we have plenty of chances to try again. It's not an instantaneous window, so we'll have a few hours, but we do know that the wind is looking best at the beginning of our window. So we're hoping to light that candle at the very start of our window.
Sounds good to me. Again, 26 minutes and counting to the opening of that window. Teams monitoring winds, but otherwise everything tracking on track for launch. And again, keep those questions coming into chat. Tag us with @NASASpaceflight, and we're going to keep them coming till we get to that business end of the countdown. To preview a little bit, I believe we'll get into that terminal count bit just about 15 minutes from liftoff, so we're just over 10 minutes away from things really kicking into high gear here. In the meantime, let's go ahead and listen back into the countdown net as the countdown proceeds.
Config update in 30 seconds. LC ether countdown ready for config when you are.
And Carolina, I think we have an update on the countdown as it progresses.
Yes, absolutely. Things are moving right along. We have word that we will likely enter a hold at T-minus 20 minutes for a few minutes while the team spends some additional time on software configurations, but everything is proceeding nominally at this time.
Yeah, and we'll stand by for a new T0 once that hold clears. Again, coming up on a hold in just over a minute as teams continue to just make sure the rocket is 100% ready to go. In the meantime, we have more questions, so we're going to keep those coming. And let's talk a little bit about engines and propulsion. This rocket, I believe, has 5 engines on the first stage, 1 on the upper stage. Can you talk a little bit about those?
Yes, absolutely. So our engines on this vehicle are all designed and built in-house by Astra. Our 5 first stage engines are electric pump-fed engines. We call them Delphins. And they each produce about 6,500 pounds of thrust on the first stage, and there are 5 of them. And then on the upper stage, we have a pressure-fed ether engine, which is about 700 pounds of thrust, and both stages use the same LOX kerosene propellant.
And is there a reason that Astra chose that particular propellant combination for Rocket 3?
We like to use things that are simple and efficient, and this was the right choice for this vehicle.
Gotcha. Again, we're coming up on T-minus 20 minutes. You're going to see that clock hold for a little bit. Team's just working through some final pre-launch checks. And there is that hold. In the meantime, let's talk a little bit about the history of Astra. This is the first live broadcast, and of course here at NASASpaceflight, we are very honored to be allowing us to share that with the world. And but let's talk a little bit about how Astra got here. What led up to today's launch attempt?
Absolutely. So Astra was founded in 2016 as a different kind of space company. We were in stealth mode for several years where we focused on making progress on hardware and getting plenty of launch experience under our belt. So our mission at Astra is to improve life on Earth from space, to find ways to create a healthier and more connected planet. From powering more efficient and affordable agriculture to helping the forestry industry fine-tune their sustainable practices, the implications of sending satellites to space are exponential for our global economy and populations. As we've mentioned before, Astra is headquartered in Alameda, California, which is just across the bay from San Francisco. We have a 250,000 square foot factory on the grounds of the former Naval Air Station in Alameda, and we test our rocket engines just across the street in indoor test cells that were once used by the US Navy to perform jet engine testing. We have conducted 2 suborbital test launches so far, and today's launch of LV-6 is our 3rd orbital launch attempt, with hopefully many more missions to come. And if you're interested in staying in the loop on our work and announcements, you can follow us on Twitter. Our handle is @Astra.
Definitely looking forward to this being the first of many launches to come for Astra, not just from Kodiak, but from elsewhere as well. Again, if you have questions about anything you are seeing, throw them in the chat, tag us with @NASASpaceflight, and we're going to keep going through those throughout the countdown. Again, if you're just joining us, we're in a hold at T-minus 20 minutes. Team's continuing to work through the countdown. We have a fair bit of time in today's window, so we'll just keep an eye on when that clock is released for a new T0 time. But in the meantime, propellant load still underway. You can see the vehicle getting nice and frosty as the super cold liquid oxygen flows in and the kerosene on the bottom of that. And yeah, we're going to continue to provide updates as the countdown proceeds. And again, as I say, let's listen into the countdown net. The countdown net gets nice and quiet. We will keep listening into that and checking in on how the teams are proceeding through the countdown. In the meantime, we'll keep taking some questions here. And about those launch teams, we have a question about what's the difference between a launch conductor and a launch director?
Yes, so our launch director is the final launch authority who's responsible for the safety of overall launch operations, while the launch conductor is the person who oversees and directs launch vehicle operations. It's the one who's following the countdown manual, who can call hold, recycle, or abort as required. And as we are in this hold, that is one of the responsibilities of the launch conductor. We are in this hold as the team updates their software configurations on the vehicle.
Gotcha. A couple questions about the operations around today's launch. We have one asking, how big is the exclusion zone around this rocket, and does anyone have to vacate the area to launch from Kodiak today?
Yes, we do want to make sure that safe operations of both people and property are followed. So don't know the precise dimensions of that exclusion zone, but we are working with the Coast Guard and the FAA to make sure we're clearing the airspace and we're clearing the ocean as well, and making sure that the beaches are also clear of anyone who may be a little too close to our rocket launch.
And keeping on the content or on the topic of launching from Alaska, we have a question asking, isn't that less efficient than launching from, say, Florida or someplace closer to the equator?
Well, that entirely depends on where you want to go. So our payload today, our test payload, which will not be deployed, is going to a high inclination, and Kodiak is great for reaching those types of orbital inclinations as well as polar orbits. So different launch sites can get you different access to different portions of space, and so we really like launching from Kodiak when we need to go to those polar orbits.
And correct me if I'm wrong, I think that would actually hurt you if you were trying to launch to a polar orbit from Florida, because you actually have to get rid of a lot of that extra velocity you get from being closer to the equator.
That's right.
So those low inclination missions, which launch closer to the equator, they take advantage of that. But if you're trying to launch into a polar orbit, it actually hurts you, which is why launching from up north in Alaska works so well. And also, I believe there's another benefit, at least for these early test flights, for being at a launch range that's not very busy and more remote than some of the more busier or more traditional launch complexes.
Right, definitely. One of the reasons why we have enjoyed working at PSCA, our Pacific Spaceport Complex in Kodiak, is because they've been really helpful in working with us on getting the availability that we need and making sure that we can hit our launch schedules and our targets.
We're seeing a lot of really cool venting from the pad there. You can also listen into the pad mics and hear that. It's super cool to hear. About that ground equipment though, people asking, does that launch base also fit into the shipping container, not just the rocket? I believe it's all of the equipment ships up that way, right?
Right, everything that you see here fits in standard shipping equipment. So that rocket itself fits in a 45-foot shipping container, and everything else that you see, aside from the concrete ground, does go over boats and trucks to our launch site.
Also, we're getting a really good view here of the top of this rocket, that payload fairing, and we have a question about that coming from chat. It's got a bit of a unique shape. It looks like it might even split into more than two pieces, or is it, if that's not the case, what is the deal with that cool fairing shape?
Yeah, we will hopefully see the fairing split. It is broken down the middle into two halves, and so one of the things we are really hoping with today's flight is that we see that beautiful fairing separation of the two halves coming apart, so we can complete our mission. And if we were to deploy a payload, that's when we would deploy a payload after that fairing has separated from the vehicle. But again, it is a test payload today that will not be deployed.
And a bit of a unique aspect to the Astra Rocket 3, I believe that fairing separates also not just to expose the payload, but to expose the upper stage. That fairing actually separates prior to the two stages separating, right?
Mm-hmm, that's correct.
So as we continue to move towards our eventual launch time, again, teams are currently holding, continuing to, with those pre-launch preparations. But once we can get that clock counting again, as long as those winds cooperate as well, we'll hopefully be able to see that really cool stage separation. It's very cool to see. In the meantime, if there is a hold later in the countdown, I know we did not get into terminal count yet, so we haven't had this issue yet, but once we get past that terminal count point, we're about 15 minutes into launch, How fast can that rocket recycle and make another launch attempt?
Yes, absolutely. So with this type of hold, we would pick up the count right where we left off. If we are within that 15-minute terminal count period, we would recycle the launch attempt from the top of that 15-minute mark.
For this particular version of the rocket, a question in chat about what the maximum weight for a payload on Rocket 3.3 is right now.
Right, so again, that depends on where we're launching from and where the payload wants to go. Our capacity does vary because we are a small rocket. There's some variance in where we can, how much payload we can get to different orbital destinations.
We talked a little bit earlier about Astra working to also scale up to slightly bigger rockets, hit those different payload mass goals and things like that. Astra's got a lot of long-term goals, that big one being that daily launch cadence, which is so cool just to think about that being enabled. Where do you see Astra in the next 10 years or so?
Absolutely. I think daily space delivery is something that we've said we are passionate about and we are heading towards, and so we're making strides towards that goal. And it'll also be really interesting to see where the whole industry is in 10 years from now. Thinking back 10 years ago, that was near the end of the space shuttle program, and many of these commercial launches were just coming on the horizon. It's amazing to see the progress that I don't think could have really been imagined at that point 10 years ago. So who knows where we're going to be 10 years from now, but I hope it means a lot of rockets.
For the NASA spaceflight editors watching this stream, you hear that? That was a shuttle reference. We got one in for this stream, okay? We're going to continue checking in for activity on the countdown net and listening into those patent mics as we wait for teams to continue working towards clearing this hold. If you are just joining us, we're here at Alameda's headquarters in California for live coverage of the launch vehicle 0006 launch. My name is Thomas Burkhardt. I'm a news director at NASASpaceflight.com, and joining me is Carolina Grossman, Director of Product Management at Astra. We are still in a hold right now. Do you have any updates for us?
No new updates since the last time we heard from the team. They are loading software configurations, and we are still holding at T-minus 20 minutes.
We have gone through a very large part of the countdown to get to this 20-minute mark. Teams continue to work through some issues. But in the meantime, let's talk a little bit about the launch that preceded this one. We want to show a highlight video of Rocket 3.2's trip to space. And this is what we're going to be hoping to see later today. Hopefully, there was that water deluge that we said was very dramatic, but it looks very cool. And there's only some minor changes from this Rocket 3.2 launch to the one we're hoping to see today. So should look fairly similar if all goes well.
That's right. We are hoping that we have resolved the issues that caused us to fall just shy of orbit. And we've also made some changes to increase our payload capacity on this vehicle.
This is a nice small rocket, so you'll notice that those early clips, it really likes to leap off the pad. I'm really looking forward to that. And then these stunning onboard views of stage separation and the upper stage ignition, hoping to get that live today as well.
Absolutely. It was an amazing moment here for the team at Astra to see that engine light, and that beautiful stage separation is what you're seeing now, the fairing falling away. And it was a very, very exciting and happy day for us at Astra.
Okay, in the meantime, we're going to keep taking some questions from chat, and I've got one here asking about the lightning protection system out there in Kodiak. I see I've got two phone poles with lightning rods on them. Is that your lightning protection system?
Yeah, I was going to say, you took the answer, just like Jeopardy. That is our lightning protection system.
So it is not the 4 towers that we may have seen out in Cape Canaveral sometimes, but still a lightning protection system out there for Rocket 3.3. Keep it going with some questions here. People asking, is Astra thinking about anything beyond low Earth orbit or Earth orbit?
Well, our focus and our mission is to improve life on Earth from space, so we are keeping focused on Earth orbit.
Another question from chat asking, how long does it take to manufacture one of Astra's rockets?
Right, well, we are actually ramping up for monthly production and hoping to complete 3 launches this year. So that is where we're at the moment, and hoping to continue making that faster and faster as we take steps to daily space delivery.
And can you talk a little bit about how Astra is working towards achieving not just the high launch cadence, but the low cost building price for these rockets?
Yeah, absolutely. It's certainly one of the unique aspects of our launch system is that we focus on proven and cost-efficient parts as much as we possibly can. As we've said earlier in the broadcast, many of the components that you see on the rocket come into our factory as raw sheet metal, and we have our in-house machine shop team and our production team that turns it into flight hardware. And so we try and stay away from costly and labor-intensive materials like carbon fiber and 3D printing. We do use them sparingly, but they tend to be expensive, and more importantly, they are very difficult to build at scale. So we're focused on making a production line that can build and test rockets at an unprecedented pace. So we need to aim for simplicity in that design, and as we like to say at Astra, simple scales.
Again, if you are just joining us, we're in a hold at T-minus 20 minutes as launch teams continue to work. We'll continue to provide updates as they move towards clearing that hold and moving back towards a T0.
Okay, this is Astra LC on countdown. We are at step 112. We will be doing software load, then setting ourselves a new T0 time. Tango, have you refreshed and are you ready for config loads?
Yes.
Tango, at this time, please go into machine pump battery 2, manage pump battery charge. Toggle stop charging batteries.
Copy that. Stopped.
In AV1, manage power systems. Please toggle off guidance power system authority.
Off.
In AV1, manage polling, toggle do only ground.
Only ground.
And Tango, let me know when you're ready to load new configs.
Tango's always ready.
Engine Alpha 125 Victor 7.
Alpha 125 Victor 7. Loading. Loaded.
Bravo 126 Victor 7.
Bravo 126 Victor 7. Loading.
Tango, are you ready to try to load engine Charlie?
I am.
Charlie, 127 Victor 8.
Dolphin Charlie 127 Victor 8 loading.
Tango engine Delta.
Delta
128 Victor 7.
128 Victor 7 loading. Loaded.
Engine Echo 129 Victor 7.
129 Victor 7 loading.
Okay. Tango, I'd like you to try loading ether sequence 101 Victor 10.
Ether controller config 101 Victor 10 loading.
Alright, and Tango, I'd like you to load guidance configuration 5 Victor 127.
Guidance config 5 Victor 127 loading. Loaded.
Alright, Tango with guidance config loaded, can you please give me a GNC setup, please? Calling out when complete.
Copy that. Setting up GNC.
And if you're joining us, we are still in a T-minus 20-minute hold.
GNC
However,
service
teams
complete.
are working through it.
Thank you, Tango, and an AV1 manage polling, please set us back to both ground and guidance.
And we're getting very close to a
Both
new
ground and
T0,
guidance.
so stand by. We should have a new launch time for you shortly as teams continue to resolve just some quick issues before we release the hold and get back to counting down.
Weather's still looking good, so we hope to have that new T0 very soon.
is Astra LC on countdown. We are picking the count back up at this time. We are on step 119, moving into Delphin pump spins. Tango, can you please activate machine AV1 power ESC ace dry spin?
It is active.
Tango, please toggle on power ESCs.
Power ESCs toggled.
And as you can see, we're now counting down. We've recycled the clock just a little bit now, 21 minutes and counting. That gives us a T0 of 45 minutes past the hour, 2:45 p.m. Pacific time, our new target launch time. Carolina, how are things looking for the launch attempt today?
Well, as you've heard, we were in a hold troubleshooting some software configuration issues, but that seems to be resolved. We're back into the count. The team is now completing pump spins for the first stage engines, and we'll be shortly moving into the final preparations of our pre-flight, including that water deluge test.
Gotcha. Now that the clock has resumed, we're going to take a couple more questions before we get into that terminal count section. We do have a question in chat about will there be any onboard views from the rocket. I can field that one. We are hoping to have some onboard views, but of course that is dependent on how reliable and steady that telemetry connection is. Obviously there is more higher priority data, so we can't guarantee that connection will stay rock stable, but if it is, we promise that we will be showing it best we can. You can see some of the views on there now. That's actually the second stage forward-looking camera up into the payload fairing, one of our onboard views, and we'll be showing those best we can once liftoff has occurred. And there is the other stage 2 camera looking down. You can actually see just the black outline of that Aether engine, which we will hopefully see igniting in space before too long today.
Fingers crossed.
Some other questions. We have one from chat asking, what function are those various umbilicals providing between the launcher and the rocket itself?
Yes, so those umbilicals will help pump fuel, our propellants on board the rocket, as well as provide communication, and that's how our team here in Launch Control in Alameda communicates with the vehicle. And those umbilicals will disconnect as the rocket takes off.
And it sounds like we are getting very close to that water deluge test. That'll be a nice visual indicator that the countdown is proceeding. T-minus 19 minutes and counting to the launch. Again, a new T0 of 2:45 p.m. Pacific time. And you just heard we had another quick weather brief thrown in there, and that the wind profiles look good right now, so that's another good sign as we count down towards launch. We have another question here in chat talking about the Apollo fusion, which is now involved with Astra. Carolina, what can you tell us about that?
Yes, absolutely. We are very excited to have the Apollo Fusion team and technology as part of Astra. We completed
We'll toggle off on my call.
that acquisition in July.
And really quick, I'm going to cut off that answer because we are coming up on that water deluge test.
Off.
Off.
There we go.
Tango in the water system machine, toggle pump full to false.
So Carolina, did that look good to you?
That looks like a successful deluge test.
So hopefully the next time we see that will be at ignition.
Just a few seconds before, yes.
Perfect. So, to get back to the question that the water deluge test so rudely interrupted, can you tell us a little bit about Apollo Fusion and how they relate to Astra?
Yes, absolutely. So we chose to work with Apollo Fusion because they have a system that is cost-effective and reliable at scale, which is very aligned with what we are trying to do with our rockets at Astra. Apollo measures their design cycles in months, not years, and are focusing on solutions that are easy to manufacture and assemble. And they don't see their job as done when they have something that initially works, but they continue to optimize for manufacturability and scalability, just like we do with our rockets at Astra. And earlier this week, they had some very exciting news that Apollo Fusion's thruster ignited in orbit, which is a very important milestone in our journey to provide rapid, low-cost access to space. So shout out to the Apollo Fusion team for that milestone, and we at Astra are very excited to continue our partnership.
And again, we're at T-minus 16 minutes and counting, starting to get into the business end of this countdown. One of the next big milestones is going to be the entering of the terminal count at T-minus 15 minutes, so we're just under a minute away from that. We still have some more questions. We'll get through a couple more of these, but of course, as usual, once we get into that business end of the countdown, we're going to leave it up to the countdown net to do most of the talking here. But before we get to that, we were talking about Apollo Fusion, Astra acquiring them, and we just have a question in chat that they're not super familiar with Astra as a company. Don't blame them. The first live broadcast of their launch. Are you guys headed for an IPO? I believe I might know the answer to that.
Yes, we did also IPO in July. It was a very exciting month for us, so we are a public company.
Which is very, very cool, and an increasingly prevalent part of the space community that's pretty new, but it's very cool. And again, at T-minus 15 minutes, about to enter terminal count. And there is the 15-minute mark, Rocket 3.3 now in its terminal count for the launch of LV-0006. So one of the next big milestones will come up at just about 10 minutes, a little over 10 minutes before launch, when the teams will give their final go and no-go for tank pressurization and launch. That's the next really big milestone we're going to be waiting for.
Self-check is passed.
Copy that, thank you. We have confirmed Astra FTS is still enabled on the vehicle. Tango, at this time in Fuel 4 operate, can you toggle full? Full. Fast.
Fast.
So now that we have
Tango,
entered
please
terminal
inspect
count,
the launch machine.
I don't want to talk over the countdown then. There we go. Now that we have entered terminal count and are about just under 15 minutes from liftoff, how are things looking today, Carolina?
We are looking good. We are about to set a new UTC T0.
Minutes 4-5.
And that is that 45 minutes past the hour.
4-5.
Seconds 0-0.
Second 0.
Please
So
save.
we have
Saving.
confirmed that the weather is go for launch. We have no issues with boats. The range has given us the go-ahead so far. We'll confirm that later on in the countdown.
And as we get closer to launch, this just again, for those of you just joining, let's go over the details of today's mission, Carolina.
Absolutely. So LV-6 is Astra's third orbital launch attempt and our first commercial orbital launch with the United States Space Force. It's for the Space Test Program, and by commercial orbital launch, we mean that this is a launch conducted under an FAA commercial launch license. Our goal with this flight today is to successfully reach orbit and do so with a test payload which we will not release. This orbital demonstration launch allows our team to verify numerous upgrades to our launch system since Rocket 3.2 was launched in December. Today's launch is an important milestone in our work at Astra. What we learned today will get us closer to launching our next payload. And before we get further into the count, I'd like to give a big thank you to the entire Astra team and their families watching with us today. We couldn't do this without your support. Thank you all so much. After December's launch, we've been excited to get back to the pad with LV-6. As a reminder, in our previous launch, Rocket 3.2 successfully passed the Kármán line, the 100-kilometer altitude that's commonly used as the demarcation of space. While the rocket narrowly missed making it into orbit, we were ecstatic with those results. Rocket 3.2 shut down 12 to 15 seconds too soon after depleting its fuel at a peak altitude of 390 kilometers and 7.2 kilometers per second, which is just half a kilometer per second short of orbital velocity. It's so close. And since then, we've been fine-tuning that mixture ratio between our kerosene fuel and liquid oxygen to propel us further. I also want to take a moment to recognize the efforts of Astra's Red Team. The rocket is controlled from our headquarters here in Alameda, California, and we send a team of 6 Astra personnel, known as the Red Team, to Kodiak for the launch. Because our rocket and support systems were designed with simplicity in mind, we only need a small and nimble team on site for the launch. It also helps us limit travel, which is a key consideration as the COVID-19 pandemic continues. All 6 members of our Red Team are taking regular COVID-19 tests to protect the health and safety of everyone involved in this mission. We hope you and your loved ones are staying safe out there as well.
Absolutely, Carolina. We are coming up at T-minus 10 minutes, 45 seconds and counting. We are rapidly approaching the final go, no-go pull for tank pressurization and launch. So let's listen into the countdown net and see if we're good to go.
Active.
Toggle LOX topping.
LOX topping.
Team, this is the poll for tank pressurization and launch today. After this point, any system issue must be called as a 3-word hold. If there are no concerns for flight, call go. Otherwise, call no go. Red lead.
Red lead is go.
FTS.
FTS is go.
Delphin.
Delphin is go.
Ether.
Ether is go.
Odin. Inco.
Inco is go.
Ace.
Ace is go.
Launcher.
Launcher is go.
Orbit.
Orbit is go.
Booster.
Booster is go.
GNC.
GNC is go.
FAO.
FAO is go.
CDH.
Go.
Tango.
Go.
Safety.
Safety is go.
LD.
LD is go.
LC is go as well. Tango in AV1 manage. Polling toggle do only ground.
Only ground.
Delphin, please provide flight engine sequences for us for today.
Engine Alpha sequence 785 Victor 9.
Alpha 785 Victor 9 slot 0 loading. Loaded.
Engine Bravo 786 Victor 5.
Bravo 786 Victor 5 slot 0 loading.
And as you just heard, teams have pulled go for the launch of Launch Vehicle 0006, Astra's 3rd orbital launch attempt, just under 9 minutes from now. We're now in the meat of the countdown and getting close to the final countdown towards liftoff.
And a little bit about our goals for today. We've talked about achieving orbit, but that is very difficult, and so for this reason, we're being realistic with our expectations. Today is our 3rd attempt to reach orbit and our first test with a sample payload provided by the Space Force to simulate mass. And right now, the team is loading the final flight software onto the vehicle and going through those final preparations for launch.
So now that we're just about 8 minutes away from liftoff and the teams are counting down towards that T0 of 2:45 p.m. Pacific time, as we enter those final minutes of the countdown, I'm now going to hand it off to Carolina and the countdown net for commentary of Astra's 3rd orbital launch attempt. Carolina, take it away.
Absolutely. We'll start by telling you about the major flight milestones that we'll see on this flight. They will be displayed on your screen for you to follow along. At T-minus 3 seconds, the 5 first stage engines will light. If the engine data looks good, the hold down release mechanisms will let go at T0, and the rocket will begin its trip to space. At T plus 25 seconds, we will clear the range and fly over the Pacific Ocean. LV6 will reach max Q, which is the period of maximum aerodynamic pressure on the vehicle, at T plus 1 minute. Main engine cutoff, or MECO, which signals the end of the first stage burn, will occur at T plus 2 minutes 18 seconds. This is followed quickly by fairing separation and stage separation. At this point, the rocket will be in space, just over 100 kilometers above the surface of the Earth. But then there's more if all goes well. After stage separation, upper stage ignition happens at T plus 2 minutes and 32 seconds, and then the upper stage burns for about 6 minutes until SECO, or second engine cutoff, at T plus 8 minutes and 48 seconds. Then, since we're not releasing an actual payload, the vehicle's systems will simulate a signal for payload deployment. If we make it this far, we will have made it to orbit and would consider this flight to be successful.
Now everything continuing to be on track, just over 6 minutes away from launch.
Rise to launch.
Thank you, sir.
As you just heard, we've just been given the go-ahead for launch from the range. And now in the final almost 5 minutes to T0, we expect that the vehicle will transition to its internal control at T minus 60 seconds, and will be continued to listen to the countdown in these final minutes before liftoff.
Tango at this time, please enable launch.
Launch enabled.
That's a great shot of the teams here at Alameda watching from next to Mission Control just behind us. Again, just under 5 minutes away from T0.
Four minutes. RCO LC on countdown.
RCO, go.
Please verify range is recording telemetry.
Range is recording.
Copy, thank you. Control room, if you require RF data in flight, be prepared to switch over your Grafana pages. FSO, prepare to issue option command at T plus 164, calling out at event.
FSO copies.
3 minutes.
Under 3 minutes to go to the launch of Astra LV 0006.
Any three-word hold called from here on out is an immediate abort, regardless of source. FTS, please send master enable and watchdog on AFTU.
Master enable issued. Issuing watchdog.
Minutes.
AFTU's master enable is enabled. AFTU is green, ready for flight.
Copy, thank you.
Coming up on 90 seconds, let's listen in to the final seconds of the countdown for Astra LV 0006.
"90 seconds. ACE at this time, please start PSD recordings.
PSD recording started.
"60 seconds. The vehicle is on internal control. First stage tanks are pressing. 45 seconds. First stage is at liftoff pressures, 30 seconds. 20. 15. Water on, 10, 9, 8, 7, 6, 5, 4, 2, 1. Mission 0. Abort.
Back at idle. Abort hit.
Looks like an abort was called at T0. The team will look into the issue and we will hopefully make another attempt.
Tango, confirm LOX tanks are venting.
LOX tank is venting.
Tango, confirm igniters are off and everything is in idle.
Igniters are off.
Confirmed vehicle has gone back to GSE power.
And work.
Again, abort called right near T0. Teams are currently working through their abort procedures and we're standing by for word of the next attempt.
Vehicles on GSC power.
And Tango, please deactivate launch machine at this time.
Deactivated.
Okay, going from abort to recycle checklists at this time. Odin, you are good to pull logs.
So it sounds like the abort was called by our guidance system near T0. It looked like the engines successfully lit, but the guidance system called an abort. The team is looking into the issue, and we will hopefully recycle, and we will begin our recycled attempt at T-minus 15 minutes at the top of our terminal count.
Just a reminder, there is a fair bit of time in today's launch window, so plenty of time for the teams to work through this issue and work towards their next attempt.
This is LD on countdown. We're going to scrub for the day. Thank you everybody for following along. But we need to investigate the misfire and attempt to make another go around tomorrow.
RCO copies.
All right, and as you've just heard from our launch director, we are going to stand down for the day to troubleshoot the abort that was triggered at T0. Our window does continue until September 11th, so there's plenty of time for us to try again. And we'll announce our next launch attempt on Twitter, so make sure you're following us at Astra. Thank you so much for joining us.
Yes, thank you, Astra, for allowing us to share today's webcast, today's launch attempt with everybody. And thank you all so much for watching. Stay tuned for coverage of the next launch attempt after the teams are able to complete their investigation of today's abort and see when the next attempt may be. But stay tuned for future spaceflight news coverage. Carolina, thank you so much for joining me today.
Thank you, Thomas.
Absolutely. Until next time, we'll see you then. Thanks for watching.
Propulsion continues to be normal.
RCO chamber pressure looks good. Traveling up. Roger roll, Atlantic.
Water towers, fly!
Tango Delta nominal.
Flight count speed off. Bring in SCE off.
Yikes. You bet. Concur. We don't need any more of these.